Okay. So now we'll revise the chapter first. The special part of the chapter first is that supremum and infimum. Okay. So we'll revise that supremum and infimum of the set. Okay. So what do we mean by supremum of a set? Suppose S is a non-empty subset of the set of the real number R. This is what R is the set of the real numbers. So that is the bounded above. When supremum exists, if S is bounded above, then only the supremum exists. If S is not bounded above, then supremum will not be exist. Okay. So then U is the real number. It's called a supremum of S. It is also called as least upper bound. Supremum is also called as least upper bound if U is the upper bound of S. So supremum should be the upper bound of S. No number less than U. No number less than U is an upper bound of S. That means suppose V is the upper bound of S, then V will be the greater than U. So this will not be less than U. It will be the greater than U. Okay. So this is the definition of the supremum. Note that the supremum may or may not belong to the set S. So it is may, this what the supremum is the element of may or may not be the element of S. So that means may belong to S or may not belong to S. Okay. So that means supremum may not be belong to S also. Okay. Note that this. Infimum of a set. So let S be the non-empty subset of R. Just reverse definition of this one. So that is bounded up below. So if S is not bounded below, then infimum does not exist. Okay. So infimum, when infimum exists, it should be the bounded below. Okay. So bounded below. Then U is the real number U is called infimum of S. It is also called as GLB. That means the greatest lower bound. This is what the greatest lower bound. If U is the lower bound of S. So infimum is the lower bound of S. It is always lower bound of S. Next is what? No number greater than U. No, because this is you are saying that U is the greatest lower bound. That means no number less than no number greater than U is the lower bound of S. So that means if V is the lower bound of S, then V should be the less than U. V must be the less than U. So because what? So here, so if your S is here, so these are all are the lower upper bound of this. So the numbers here all are the lower bound of S. And what is this? This is what? The greatest lower bound. This is what? Greatest lower bound. And this is what? The smallest upper bound. This is the smallest upper bound. This is called supremum. This is called infimum. All these are upper bound. All these are the lower bound. This will be the greatest of all lower bound. This will be the smallest of all upper bound. It is called a supremum. This is called an infimum. Okay. So note that this. Now we'll see the examples on it. So that are very important now here. So to find supremum infimum, that is the complicated part for you, but we will make it is very easy. So you will understand that how to find the supremum and infimum for this one. Okay. So first we will take one property, the completeness property of R, and then we will go to the examples of the supremum and infimum. The completeness property of R. Complete property of R. You should remember this. Every non-empty set of real numbers that has an upper bound also has a supremum in R. Okay, that this is obvious, but this is called a completeness property. It is obvious. So every non-empty set of real number that has upper bound. So if it has upper bound, means it is bounded above. That means every bounded above set has the supremum. That is what the completeness property. Okay. Then you have the Archimedean property. If x is greater than 0, then you should remember only this. You don't have to mugging of this one. Okay. पाठ करायची नाही, फक्त लक्षात ठेवायची. Let x greater than 0, then for any y belongs to R, there exists n belongs to n, there exists n belongs to n such that nx is greater than 1. Nx is greater. For x greater than 0, that means x is positive, and for any real value y, there exists a natural number n such that nx is greater than y. So x is greater than 0, n is natural number means nx is also greater than 0, y is a real number then. Okay, so that y is less than nx now. Y is less than nx. That means nx is greater than y. This is the Archimedean property. Okay. Now one by one we will see how to find supremum, infimum, lower bound, upper bound, bounded set. All examples will be there. Okay. Suppose S is this set. X belongs to R such that 0 less than equal to x less than equal to 1. Okay. So this is the first example. We'll find the supremum, infimum, lower bound, upper bound. So lower bound, upper bound, no problem. But now this I can write this as what? 0, 1. Right? So x belongs to R such that x lies between 0 and 1. That means this is a closed interval 0, 1. Now this closed interval 0, 1 is always bounded set. So that means it has a lower bound, it has an upper bound. Okay? And whatever this S is your lower bound, and that will be the infimum. So your infimum is what? 0. Your supremum is 1. For interval. The right hand side is the supremum and left hand side is the infimum. Okay? But suppose your S is like this. 0. X belongs to R. So that 0 less than, strictly less than x less than 1. So that means this is open interval. They will provide you open interval also. Supremum of this interval. So now here also what here? So this is interval. That means this is all numbers lies between 0 and 1. Okay. So every number is greater than 0 and every number is less than 0. That means your 0 is the lower bound and 1 is the upper bound of this one. So now this your infimum is 0 and your supremum is 1 now here also. Okay. So even though your set is like this, so your set is like this, all answers are same. All answers are same. But suppose your S is like this, x belongs to R such that x is less than equal to 5. X is less. That means what your set is what? Minus infinity 5. This is close 5, no problem. Close 5. Then here what? This is not bounded below because this is minus infinity. Is not bounded below. So if set is not bounded below, then infimum does not exist. Infimum does not exist. So it has only supremum. So supremum of S is what? 5. And infimum does not exist. Does not exist. Like this interval. Okay. So same thing here what? So if your interval is minus, open 5. Answer is same now. Supremum is 5 and infimum does not exist. But if your interval is like this, 1 infinity suppose, then this is what? Not bounded above, because what? Upper bound does not exist here. Okay, so we cannot say all the elements are less than this number. Okay, all numbers are less than infinity, but infinity is not a real number. So this is not a bounded. This is not bounded set. It is not bounded above. So but it is bounded below. If it is bounded, and if a set is bounded below, then infimum exists. So your infimum is 1. Your infimum of S is what? So your S is like this. So infimum is 1 and supremum does not exist. So if you write here this, then what? Again your infimum base is 1. So note that the supremum infimum may or may not be the member of A, member of the that set, whatever this. So here what? 1 is not a member, 0 is not a member. Okay. So here both are the member. No problem for this one. Okay. So for the interval, I hope that you understand for the interval. Okay. So those set we have supremum and infimum, that set is bounded. Okay. The supremum does not exist. In supremum or infimum both does not exist. That means set is not bounded set. The set is not bounded set. Okay. Suppose S is now this is 1 by n. N belongs to n is a natural number. N is a natural number. So how we can write this? N is natural number means it is 1, means this is 1/2, means this is 1 by 3, 1 by 4, dot dot dot, dot dot. Right? So now see here, denominator increases, the number tends to 0 but not 0. Number tends to 0 but not 0. Right? So that means what? All numbers are become smaller and smaller, tends to 0. And that means what? Here all numbers are greater than 0. That means all the numbers are greater than 0 and all the numbers are less than 1. Okay? So that means what here? So this is what then supremum of S will be the 1. Because 1 is the greatest of all this. Okay? All numbers are less than 1 now here. But all numbers are greater than 0. That means infimum of S 0, right? Infimum of S is 0. Easily we can do this. Okay? As n tends to infinity, you know that as n tends to infinity, 1 point tends to 0. So this number goes to 0. But not 0 now here. But 0 is the infimum of S and 1 is the supremum of S. 1 belongs to S but 0 do not belong to S. You should remember this, supremum and infimum of the set. Very nice example of this one. Okay, suppose S is equal to 1, 3, 7, 98. This is a finite set. Finite set is always bounded set. So that means what here? Supremum. Supremum is what? 98. What is the biggest of this one? 98. What is the infimum of S? 1. So this is bounded set. Supremum is 98. Infimum of this. Okay. So suppose S is equal to 1 by n, just we have taken. This is what? Bounded set. 1 by n is the bounded set because we have seen that 0 is the lower bound and 1 is the upper bound. If both the bound exist, then that set is the bounded set. Okay. Suppose S is equal to minus 2, minus 3 by 2, minus 4 by 3, minus 5 by 4, dot dot dot, minus n plus 1 upon n, dot dot dot, dot dot dot. Now see here, minus n plus 1, n plus 1, n plus 1 upon n. Okay, so that is what? Minus 1 plus 1 by n, 1 by n. Okay, so the last term of this one will be. Okay, now see here, this is minus 1.5. This is minus 1.5. Okay, minus 1.5. What about this one? This will be what then? Minus 1 point. Minus 1.3333. Okay, this is minus 1.25. Minus 1.25. Minus 1 point. Okay, so that means what here? These terms goes to minus 1. Because what? If n is very large, then this will be 0. So that means what? This term tends to the minus 1. All terms tend to the minus 1. That means what? Here what? This is minus 2. Minus 2. Okay. This becomes greater and greater. So this term is greater than this term. This term is greater than this term. It tends to the minus 1. So what is here then? Your supremum of S is minus 1. Your supremum is minus 1 and your infimum of S is minus 2. Because minus 2 is the smaller than minus 1. Okay. So that means this set is the bounded set. This set is the bounded set and supremum of S is minus 1. Infimum of S is minus 2. Okay. Next, S is equal to 1 plus minus 1 raised to n upon n. N belongs to n. Okay, we'll write the number. Suppose n is equal to 1. N is an actual number. Okay, so n is equal to 1, then this is minus 1. Okay, so this is 0 then. Your first number is 0. What about the second number then? 1 plus, this will be half then. This will be half. Okay, half, that means this is 3 by 2. This is 3 by 2. Okay, so now x is equal to 3 now. So then this is what? 1 minus 1 by 3. So 1 minus 3 is what? 3. So 2 by 3. This will what then? 2 by 3. Okay. Now then n is equal to 4 now. So if you take n is equal to 4, then this is 1 by 4. This is 5 by 4. So this is 5 by 4. This is 5 by 4 and so on. Okay. 5 by 4 and so on. Okay. What is this then? This is 0. Then this is what? 1.5. This is 1.5. What is this then? This is 1.25 something like. So this is what? This is again point something. Okay. So 0 is there, no problem. All are positive now here. All are positive. All are positive here because what? 1 by n is the less than 1. The number is less than 1 always, right? So all are positive this one. But here what? So 1 by 25 this. That means what? It tends to 1 now. This tends to 1. Okay? Becomes smaller and smaller but tends to 1 now. Okay? So then what is this then? Supremum of S is 1 now and infimum of S is equal to 0 now. Infimum is 0. Okay? Oh, not 1. It becomes this is what? 1. 3 by 2 is the greater number. This tends to 1. So, but the 3 by 2 is the biggest number. This is 3 by 2. This 1.5 tends to 1. So 1. This becomes smaller and smaller. But this is 1.5 the biggest one. So 3 by 2 is your. Okay, this is wrong actually. So this was correct. This 0 was the correct. But 3 by 2. This was the 3 by 2. For 1 plus. What happened for 1 minus now? If you take minus here, then what happened? If you take minus, we'll write the number now. If n is equal to 1, then this will be 2 now. If n is equal to 1, so this is minus minus become plus. Okay. So if n is equal to 2, then this is what? 1 minus half. 1 minus half. So this is what? 1 minus half is half now. This will be the half now. Okay. If n is equal to 3, then this is 1 plus 1 by 3. So this is what then? 4 by 3. 4 by 3. So this is 4 by 3. So 1 point something like this. Okay. So n is equal to 4. Then this is what? 1 minus 1 by 4. So this is 3 by 4. This is 3 by 4. And so on. And so on. Okay. Okay. Now see here. Okay. So what is this? This is 2. Then this is what? 0.5. Then this is what? 1 point. 1 point something. This is what? Point. This is greater than 5, but okay. So 7.7 something like this. Okay. Now see here. This becomes greater and greater now. This becomes greater and this middle one becomes smaller. So, but this is 1 now. It is 1 point something. Okay. Now this is what then? Supremum is 2 now and infimum is what? 0.5. Infimum 0.5. Because what? The number, smallest number is half only 0.5. Because this becomes greater and greater now here. And this becomes smaller and smaller, but it is 1. Value becomes smaller, but it is 1. Goes to 1 now. It goes to 1. Okay. So now your supremum 0.5 is this is half. Okay. So your half is the infimum and this is the supremum. Okay. Now suppose you have the set minus 1 raised to n upon n. N belongs to n now. Okay. So we'll do for this one. Minus 1 raised to n. Minus 1 raised to n. Okay. So what is this? If n is equal to 1, then this is minus 1. If n is equal to 2, then this is half. N is equal to 3, then this is minus 1 by 3. If n is equal to 4, then this is 1 by 4. Dot. Okay. So now what is this? This is minus 1. This is what? 0.5. This is minus 1.333 something like this. But it is negative. Then what is this? This is 0.20. 25.25. Now see here. This. Okay. So this becomes smaller and smaller. That means 0.5 is the greatest value. 0.5 is the greatest value. The supremum of S is what? Half now. That is 0.5. And see here, this negative actually, this tends to 0 actually. It tends to 0. but that will not a 0, but that will be not a 0. The minus 1 will be the infimum then. So infimum of base is minus 1. It becomes 0. It becomes 0. So minus 1 is the smallest of all this. Okay. So that means this is minus 1. So what here? Supremum is half and infimum is minus 1. You should remember the set and this value. Okay. So now S is equal to 1 minus 1 by n. N belongs to n. 1 minus 1 by n. Okay. So what is this then? So S is equal to, if n is equal to 1, then this will be 0. If n is equal to 2, then this is half. If n is equal to 3, n is equal to 3. So this is what? 2 by 3 and so on. 2 by 3. So what happened here? The numbers decreasing now. The supremum of S means 1 is the biggest one. 1 is the biggest one. Okay. And now the number tends to 0 now. The number tends to 0 now. See here. This becomes smaller and smaller. So infimum of S will be 0. Infimum of S will be. What happens? So here what? This value is the 1. 1 by n will be the 1. Then this will be 0. Oh, here what? If you take n is equal to 1, then this is 0. This is 0, 0. If n is equal to 1, then this is 0. Okay. Now see this number. This is 0.5. This is increasing now. This number is increasing, not decreasing, increasing. So this is 0.5 and this is what? 0.6 now. Something like this. So what here then? If this is 3, 4. 4 is what? 1 minus 1 by 4 is what? 3 by 4. This is what? 3 by 4. So 3 by 4 means what? 0.7. That means what? Number is increasing. So then this means what? Increasing but not greater than 1. It will not be the greater than 1. Will not be greater than 1. So supremum of base is 1 and so if you have this set, then supremum of base is 1. That means what? This is 0, then 1 and this is what? This will be 1, then 0. So maximum value is 1 and minimum value is 0. Easily you can write this. Okay. The next set now. S is equal to 2, 4, 6, 8. Okay. What is the supremum? Supremum of S, infimum of S. The finite set is always bounded. Supremum, infimum may exist. Maximum value is the supremum, minimum value is this. Okay. Now suppose S is equal to minus 1, minus 3 by 2, minus 1, minus half, not 3 by 2, minus half, minus half, minus 1 by 3, minus 1 by 4, dot dot dot. Now what is this? 0.5. What is this? 0.3, 0.25. Right? So but minus now here. But minus. Okay. So now these numbers tends to 0 now. These numbers tend to 0. And 0 is the biggest one now. 0 will be the biggest one. All numbers are greater than 0 then. Okay. Now your supremum of S will be the 0 now. Because 0, all the numbers are greater than 0. Because all numbers are negative. All numbers are negative. That means all numbers are greater than 0. So that means what here? 0 is the supremum. And all numbers are greater than minus 1. All numbers are greater than minus 1. So infimum of S is minus 1. So note that this. If the set like this, then your supremum is 0 and infimum this. Okay. So now your set is S minus 2, minus 3 by 2, minus 4 by 3, minus 5 by 4, dot dot dot. Dot dot minus n plus 1 upon n. We did this problem, I think. Yes, we did this problem. Okay. Now, irrational numbers between 2 and 3. You want irrational number between 2 and 3. Right? Irrational number, not a rational number, note that. We'll find a rational number between 2 and 3 also. Okay? So first we'll find an irrational number between. So what is this? 4 is less than 5 is less than 9. Right? Now take the root on. So 4 less than root 5 is less than root 9. So this is 2 less than 5 less than 3. Okay, so root 5 is the irrational number between 2 and 3. In this way you can find this, right? So if you want a rational number now, rational number between 2 and 3 now, rational number between 2 and 3. How to do this one? Just we write 200 less than 225 is less than 300. Between root 2 and root 3. Between root 2 and root 3. Okay, that we will do. Okay, so now this is what I can take the root on both sides, root on all sides. Okay, so what is this? This is 2 root, not this, 10 root 2. 100 into this. This is what? 10 root 2. 10 root 2. And this is what? 15. This is 15. Okay, and this is what? 10 root 3. I can divide by 15. So this is 2. 15 by 10 less than root 3. Okay, so 15 by 10. 15 by 10 means what? 5 by 3 by 2. 3 by 2. Okay, 3 by 2 is the irrational number between this and this. Okay, so I hope that you understand this one. Okay, find irrational number between the rational number 7 and 8. 7 and 8 you want. Okay, between 7 and 8 you want. So what? Same thing here. This number is also between 7 and 8. Okay, root 5 is also between 7 and 8. No problem for this one. Okay, so many numbers you can find. So 7 and 8. So here what? 49 is so I can take any number. 64. I can take the 57. Doesn't matter. You want irrational number. Any irrational number you want. I can take any number between 49 and 64. And if I take the root on this one, I get irrational number. Infinitely many irrational numbers are lies between any two real numbers. Note that. Infinitely many irrational numbers lies between any two rational numbers. And infinitely many rational numbers lies between any two rational number. So note that this. Okay, so I hope that you understand how to find the supremum and infimum of the S. Okay, so at least do these problems again and again. Okay, so you can face the exam, any exam, any competitive exam on this. Okay, so now we stop here. Thank you.